I built a custom geometry node system that uses the position of points on a point cloud to project temporally and spatially coherent brushstrokes on the surface of any 3D mesh. Unlike most common methods for creating painterly renders in Blender, which use camera-facing quads to distribute brushstrokes across a mesh, with this method, the brushstrokes are distributed in texture space. This means that it does not create new geometry for each brushstroke, and it also doesn't clutter the scene with thousands of quads, which can get quite distracting when working with large scenes. And in this video, I'm going to demonstrate how it works and how you can use it to stylize your own renders. But before I begin, I would like to quickly just mention a few things I think you should be aware of. First off, I'd like to apologize for the resolution quality of this video. Unfortunately, the computer I'm using to record this demo is not a really powerful computer at all. Not only because of the quality of the screen recording, but also because this would also affect the performance of Blender. So it's good to keep in mind that whatever performance you experience or you see in this video is not indicative of the performance that you should expect when using a fairly competent PC. But at the end of the day, it's still quite performant even on my computer, and I'm still able to use this system pretty effortlessly. The next thing I'd like to mention is that this system is still evolving, and I would love to hear from the Blender community on what works and what doesn't, and ways that it can be improved in the future. So if you're interested, you can actually test this system out for yourself for free. I have a link in the description that will lead you to a page where you can download the demo and you can follow along with this tutorial and learn about how the system works, and you can use it in any of your projects. You can also get the final blend file created at the end of this tutorial for $3. I would also like to mention that I am currently in the process of creating this system into an add-on that will automate a lot of the processes that you will see in this video to make it more streamlined and easier to use. Once you've tested it out and you like what you see, you can support the development of the add-on over on Patreon. Any support is greatly appreciated. And if you subscribe, you get instant access to new updates, assets, textures, blend files, and specialized tutorials. And you will also get higher priority when it comes to feedback and requests. Besides Particle Painter, there is also a lot of other scenes, shaders, tools, and experiments that you might find quite useful. And finally, I and the two other people that make up this Way Up Studios are currently working on an animated short film using this painterly system. Our goal is to stress test the system in a full production environment to fast track the development and find ways that it can be improved to serve a proper production workflow. So yeah, I hope you like it, and please like and subscribe. Once you've downloaded the file, it's pretty much a folder that contains all these different items. And what we care about right now is this file called Particle Painter Demo. Particle Painter Demo contains all the different assets and node groups that we're going to be using to create the effects that we want. And to have access to all the different assets in any blend file that we open, we're going to move this to our assets folder in our Blender roots directory. So to do that, we need to go over to where we have Blender saved installed, right? So I have Blender installed in my program files, Blender Foundation folder, and I'm using Blender 4.5, so I'm just going to go to Blender 4.5 and open 4.5 again, and data files, and then assets. So this is where we're going to put this blend file. Right? But before we do that, we need to create a new folder, and we're going to name this Particle Painter. And then we're gonna drag this here. All right. So once we do that, we'll open up an empty Blender scene. And if I will go over to my asset browser, you will notice that we have five new assets added to our asset browser, and these are the assets we're going to be using. All right, cool. So I'm going to go ahead and open the starter file. So here we are in the starter files. It's a pretty basic scene. Most things have already been set up, so it's easy for you to just follow along with the tutorial. And yeah, so this is pretty much all there is to this scene. There's not really much to it. There's a bunch of lights, there's a camera, there's a bunch of planes acting as negative fill, and then there's walls and a ceiling, and that's about it. And there's also animation on the camera. So when I press play, you're gonna notice that the camera is gonna orbit around our subjects. Over here we have, our regular material for each object. We can see our material node group over here, and on this side we can see our compositing node tree, and on the top here we have our asset library, and we can see the assets that we just added to our asset library. And here is our main viewport. There's not really that much to it. If you were to go into rendered view, this is essentially what you're gonna see, which is a very simple scene. And yeah, that's about it. To begin, well, we're gonna start with the pumpkin first, and then we're gonna work our way from there to other parts of the scene. And the first thing we're gonna need is we're gonna go over to our asset library, and I'm gonna scroll down and select the texture splat asset. Now this is a geometry nodes node group, and so all we need to do is drag this and drop it on our mesh. And now if you go over to the modifiers tab, you'd see that we now have a new geometry nodes modifier called texture splat. And right now we can't see anything yet, and that's because of a couple of different reasons. The first is that this show points checkbox is unchecked. When you click it, now you can see that we have a point on our mesh. I'm just gonna isolate the pumpkin for now. So now we see we have a point on our mesh, and so this is a good start, but it's just one point, right? So how do we get more points? Well, that's going to involve us playing around with some other settings. So the next setting is our point size, and this allows us to control the size of the points. This doesn't really do anything aside from, change how the points look like in the viewport. And so we can adjust that to our liking. And then we have the seed value. Now this seed value allows us to control the seed, what we're using to distribute our points on our mesh. But by default it's set to 1. And you would generally want to have this show points option checked off, because we don't want to see our points in our renders. There's also a certain reason why you don't want to have this checkmark on, and then we'll get to that pretty soon. Next, we have seed evolution. Now, seed evolution allows us to also control the seed, but this is what we would most likely be animating if we wanted to animate the seed of the points, right? If we wanted to make the brush strokes look as though they were moving around, sort of give that more impressionist, painterly effect, as though each brush stroke is being painted every frame or every other frame, we would most likely use this seed evolution to control that. And the reason why is because, let's say for example, we duplicated the mesh, right? So now we have a second mesh with the same seed and everything. If we control the seed of this particular mesh, we can move the seed around. And so what this means is essentially we can have a duplicate of our mesh, and we can still use the same modifier and the same nodes and everything, but they can look different by just changing the seed value, right? so the brush strokes don't look copied across both of the meshes. If we wanted to animate this for both of them, rather than like setting keyframes, use drivers, and one of the simplest drivers is to just do a hashtag frame, and now every frame the seed value is adjusted. So whatever the frame number is what the seed value will be. So our frame number now is frame 139, and our seed value is also frame 139. So now you'd imagine that if that's the case, if we were to do the same thing here, we would essentially have the same seed because both our meshes exist in the same timeline, right? So they'll come over here and animate my seed value in hashtag frame. Now you see that we have our seed being exactly the same, which is not what we want, right? We want to have different seed values animating across different meshes or even the same mesh duplicated, right? To solve that, we use our seed evolution field, right? So I'm just going to undo all of that. And now they're both different seeds. If I want to animate this, what I'll just do is do hashtag frame. So what I like to do is sometimes I just like to divide it by 2, so it animates every other frame, or it could even divide it by 4, and then it animates every 4 frames, right? So let's go with dividing by 2 for now. And then if I were to hit play, you see every other frame, our seed is changing. If I were to come over here and also do the same thing for the seed evolution, hashtag frame divided by 2. Now once I hit play, you see that we're not copying the same values across the duplicates. So that's pretty much what seed evolution does, right? So the density minimum essentially just says what's the minimum density between the points. And this is essentially used to prevent points from overlapping each other. This also affects the number of points on our mesh. In order to see this better, let's reduce the distance to 0. So now we have a second point in our mesh. Part of the reason why we had only 1 point on our mesh was because the distance was quite large. So I'm going to leave this at 0 for now so I can talk about the next value, which is our density max. So as I increase this value, you're going to notice points will also increase. So we're going to be layering the brush strokes. We're going to have one layer and then we're going to have a second layer on top of this. For the base layer, I like to go not too high. The more broader brush strokes are going to be laid out first. Then we're going to have much finer brush strokes, smaller brush strokes on top. So I'm just going to go for maybe a density of 100 for now. Right? So now this is cool. Right? We have this. I think I'm going to go a bit more. Let's go 300. Cool. This is enough. Don't have to go too crazy with it, so we don't have to calculate, millions of points, right? Now you notice that we have points overlapping. Part of the reason why points are also overlapping is because of the point size. So if you have a pretty small point size, the points might not overlap, but you might also realize that these 2 points are too close together, and it might also affect the way the brush strokes are sampled. So what I like to do, I just like to have a little bit of a buffer between points, and I also like to have my points sort of represent the size, not perfectly, but I know that, okay, I'm going to have bigger brush strokes, so I would like to have bigger points to just have that visual identification that these brush strokes are going to be quite big, right? So what I would like to do is increase the distance minimum a bit. Moving on, we have density factor. Now what this does is essentially gives us a range from 0 to 1 that allows us to control the density of our points. So when it's on 0, we don't have any points, and when it's on 1, we have all the points that we initially set up before. Now because this is a value from 0 to 1, you could imagine that this would actually be useful for something like textures or vertex painting, just to control parts of our mesh where we want to have brush strokes and parts where we don't want to have brush strokes. Because right now we are distributing points on our entire mesh, but let's say we wanted to distribute points only on, for example, the crevices of our pumpkin, or inside this part of our pumpkin, or underneath our pumpkin. The density factor is what will help us achieve that. Click on this button right here, right next to the slider. This tells the modifier that we want to use an attribute to control the density of our points. And right now it's essentially 0 because there is no attribute associated with it. And to get an attribute, what we need to do is go over to vertex paint mode. And to do that, I'm going to click on this drop down and go over to vertex paint. And so I'm going to change this to whatever name. So I'm just going to call it density for now. And now we have an attribute called density. So we can go back to our modifier and click on the field and then look for density. This is our attribute. And now our points are back. But as you can see, we still have exactly the same thing we had before, right? Our points still show up on pretty much every part of the mesh. To mask out certain parts of our mesh, what we need to do is change our vertex color, because right now our vertex color is set to white on the entirety of our mesh. But if we wanted to set the vertex colors to black, what we need to do is select this color right here and change it to black. And now if you click on paint and click select vertex colors, and now our vertex color is black. And then we can come over here again and set it to white. And now we can paint on parts of our mesh where we want to have brush strokes. We can decide, oh, we want to have points on this part of our mesh, but we don't want to have points on this part. But let's say we want to have points over here. Now we can have points, and so on and so forth. And if you wanted to paint, let's say you wanted to erase what we've painted, hold down Control and then paint. And now I'm currently painting the second color on this palette. So left clicking will paint white, and holding Control and left click will paint black. Right now we're not going to be using this for this particular layer, so I'm just going to come over here and delete this, and then I'm going to click on this button to reset the slider. Okay, so I'm going to go back to object mode. So next we have UV map. Now this allows us to select what UV maps we're going to be using to define what our tangent direction is. And it's not important that your UV map has to be perfect, but you're going to need to have a UV map. And depending on where your mesh was initially authored, your default UV map might have a different name. And to confirm this, what you need to do is go over to the Data Properties tab, and you're going to find the UV map section over here. And you're just going to confirm that this name here is the same as the name here. Again, your UVs don't have to be perfect. You can get away with an automatic UV unwrap, so you don't have to worry about having perfect UVs or anything like that. Moving on, we have direction. And this is going to make a lot more sense once we go further into the tutorial. But essentially, it just tells us whether we're going to use the X UV direction or the Y UV direction as our tangent vector. And we can also use an attribute to control this as well. And so once you click the button right next to it, you're going to have the option to select an attribute that you can use to control the direction. Again, we're going to use vertex painting, control the direction. And now we can create a new vertex color attribute by going over to vertex paint. And I'm going to name this direction, for example. But this time, instead of painting black on white, we're going to actually use red and green. First, I'm going to have to assign a value of black to my entire mesh. I'm going to come over here again and select red. So I'm just going to change this to red. Now it's a pure red. And then I'm going to paint. And so what's going to happen is whatever part of our mesh is red, our tangent direction is going to follow the x-axis. And then we can also then select a value of green for the secondary color. And now pressing Control and right click, we can paint on green. And so wherever we paint green, our tangent direction is going to use the y-axis in UV space. So that's pretty much what this does. And so we can use this to control the direction of our brush strokes at each individual point, depending on what we want. Okay. And again, don't forget to select your direction over here as well. Okay, but I'm just gonna delete this again because we're gonna come back to this at another point. Okay, so moving on, there's actually more fields over here. If you select this drop down arrow, you're gonna see even more fields. But essentially, all these fields are actually the same. They're actually mirrors of each other. They allow us to define the names of the different attributes that we're going to be using in our material to sample our brush strokes and do a bunch of other stuff. We're just going to make sure that whatever we name our tangent space coordinates over here is what we also name our tangent space coordinates over here. And so what I do is I simply come over here, I name my attributes, and then I copy, and then I paste. And I do the same for the rest. Now, making this into an add-on will simplify this process so it doesn't feel as tedious as it is right now. But for now, this is what you're just going to have to do. Usually what I like to do is I actually like to name this T space coordinates, chords, right? And then I like to name this point normal. Then I name this point position. And then I'll name this point tangent. And then I leave this as point random. And then I come over here and do the same. Okay, and now we're ready to actually start sampling our brush strokes. Okay, to do that, all we need to do is come over to the shader editor. We're gonna go Shift A and search for attribute. And now we have an attribute node. What I'm gonna do is I'm gonna duplicate this 5 times, right, for all the 5 attributes that we have in our geometry node modifier. And then I'm gonna come over here and copy them and paste the names of the attributes. Now we don't need to use every single attribute, but it's good for us to at least know what these attributes look like in the first place. So now we have all our attributes in the editor. To actually preview these attributes is really simple. All we need to do is go over to Material, Preview. So right now we're just looking at the base pumpkin material. But we can actually preview our attributes by pressing Ctrl Shift left click on each of the attributes, right? And so now you can see what each attribute looks like, right? So our tangent space coordinates is essentially the position of our points, but in tangent space rather than object space. Point normal is the normal at each point. Point position is the position of each point. Point tangent is a tangent of our mesh at each point, sampled from our UVs. And then point random is just a random value per point. So it gives us a random color for each point, similar to how the Voronoi texture node works. What we need to sample our texture is our tangent space coordinates. And now, in order for us to actually sample our brushstroke texture, the node group we need is the T-space sampler node group. And so I'm just going to drag this into the shader editor. And so this is a pretty straightforward node, allows us to sample brush strokes using their attributes. And now, once we plug the tangent space coordinates into the tangent space coordinate socket, and we preview our sampler, and now you can see that what we have looks really similar to UV coordinates. And so we can use this to actually sample our texture now. And to do that, I'm going to bring in an image texture. And then I'm going to select the brush stroke texture in the file that you downloaded. And then I'm going to plug in the sampler into the vector socket. And then once we preview this, now we have our brush strokes on our mesh. And the rest of the options in the tangent space sampler node group is actually used to control the location, the rotation, and the scale of our brush strokes. These can actually come in quite handy if you want to add a bit more variation to your brush strokes, and you can do that using these attributes over here. So for instance, you could use this point random, which gives us different value at each point, and then we could just plug this into the rotation. So to do that, I'll probably need to like combine, just plug the factor into the Z and then plug this into the rotation. And now we have a different value of rotation at each point, right? So you can use this to add more randomization. Obviously, everything is like super random. You can like clamp these values between a certain range if you wanted them to sort of not rotate in every different direction. So that's that. The final option is derivative offset. Now what this does is it allows us to offset brush strokes on the X and Y axis at the same time. So if I were to plug the X derivative in here, now when I adjust the value, you see that it's moving in the X axis. And then same for the Y. For now, I'm going to use the first one. We're going to use these two later on. So moving on, we have our brush strokes on our mesh, which is great. It's not super noticeable on this mesh, but if you look over here, you can notice that although we have the point here and we have no points here, we're still getting brush strokes on this region of our mesh where there are no points at all, which could be a good thing. But the problem is that the reason why we're getting brush strokes here is because the brush strokes that are being projected from on this point here are being stretched into this region. So along this axis, and also from here to the brush strokes are being stretched towards this region. So they're all converging here. And so it's causing our brush strokes to be stretched, which is something that we will not want. Now, it's not super bad here, but in certain objects, it will be really noticeable. So in order to fix this, what we need is another node group. And the node group we need is our splat mask. And this is also another shader node group. So we just drag this and put this here. And now we have a new node group. And what this node group does is it accepts the color value of our brush strokes and our brush alpha. Most of the changes that are going to be made in this node group are going to affect the alpha. But before we are able to see that, what we need to do is we need to set up the remaining nodes. So what we need to do is we need to grab our tangent space sampler. It should also actually be called tangent space coordinates. So this will probably look different for you. All right, so you're going to plug the T-space coords in here. So now we have a mask, ensuring that our brush strokes remain within the region of where the points are. And if you were to look at the previous one, you'd see that the parts where our texture is stretching no longer have any brush strokes. Next, we need point normal, which is over here. So I'm just going to grab this and put this here. And yeah, those are all the attributes that we need for this node group to work. Now, the brush stroke contrast actually affects the output and not the alpha. I think this is perhaps the only value here that affects the output of our brush stroke image itself and not the alpha. Right, so if you were to adjust this, you notice that we are increasing the contrast in our texture. And then the next option is mirror projection. Now, by default, it's set to 1, and you would most likely want it to be set to 1, but in certain cases, you might not want it that way. Okay, so in order for me to let you see what it actually does, I would reduce the density of my points to where it's a lot fewer points on my mesh. I'll just come over here and go from 0.03 to 1.5 again, like it was before. Now we have 1 point on our mesh. You'll notice that although the point is on top, we're still getting brush strokes underneath our pumpkin. And we also get a lot of stretching too, which is why in our alpha mask, we actually don't get that. But we still get our brush strokes showing up on the opposite side of our mesh. This is where the mirror projection comes in. So if I were to turn this off, now we only have brush strokes on this side of our mesh. But I usually leave it on. I think it's best to just leave it on because it allows us to cover more area with less points. We can go back to 0.03 now. And now we have our brush strokes back. Okay, cool. So now we have this, but this still doesn't really look right because this is not our final output. But let's go on with the other parameters. Okay, so next is mask size. Now this allows us to control the size of the mask, so we can increase our mask size and reduce our mask size. You know, the bigger your mask size is, the more apparent the seams will be, but you don't have to worry too much about seams. At the end of the day, the seams don't really affect final results as much as you would think. Next is mask roundness. Here you can make your mask rounder in case you want to reduce the sharpness or like the right angle feeling of the brush strokes. You can adjust the roundness. I typically don't really adjust it that much, but there are some cases where I do. And then next is fall off fade. So what this does is it adjusts the fall off of your mask, either pushes it in, pushes it out. I usually don't touch this value. A lot of these values I leave at the default values because I think for the most part they work really well, and you can get a bit too carried away when tweaking values and it might be a bit too distracting. So I tend to just leave these the way they are unless I really need to adjust something. And next is also mask fall off shrink. This allows us to shrink our fall off. You might notice that there's actually a difference between fall off fade and fall off shrink. Fall off fade reduces the size while still giving some kind of fall off, while shrink gets a lot sharper. And then we have mask opacity. This allows us to increase or reduce the opacity of our mask. And then the last one, it's pretty important, is density factor. Right now we don't need it because we are distributing our brush strokes across our entire mesh. When you need the density factor is when you're painting where you want your brush strokes to be using vertex colors. Then you get that attribute. So the attribute that you're going to usually put in here for your density factor over here, the same attribute is what you would also plug in here. And this allows you to properly mask where you want your brush strokes to be. When we get to when we're going to use this, you will learn a bit more about why this is here and how it works. That's this node group done. So we need another node group. And the next node group we're going to get is the layer splats. I'm just going to drag this and put this in here. And it's a very simple node group. It's essentially a glorified mix shader. However, it's set up in a way that makes the most sense for this particular setup. You use this to layer your brush strokes. So once we have a second modifier in here, we can then plug that in. But for now, for the first layer, what we just need is our bottom layer to be black. And what we need to do is plug in our alpha into the top alpha, and our bottom layer is black, and then we plug the outputs of the previous node group into the top layer. And then once you preview this, now you see our actual brush strokes, because what we were initially looking at was the alpha, not the brush strokes. So now we're looking at the actual brush strokes. So now we have our brush strokes on our mesh. I would like to reduce the timing of our brush strokes just a bit because I want broader brush strokes. So what we need next is the second layer of our brush strokes. And we actually don't need too many brush strokes. These might not look like much, but they actually go a long way. So what we need to do next is just duplicate this modifier. And now we have a second point cloud. What I would like to do next is reduce the size of this point cloud so I'm able to tell which is which. And also this point cloud is going to be a lot denser, so we need it to be a bit smaller. So I'll go with 0.003. if you look down here, you notice regulation warning that says input geometry has unsupported type point cloud. And that's because the previous modifier has show point clouds on. So if I turn this off, now you won't see that error anymore. And the error actually manifests itself in the way our brush strokes appear. If I go back to material preview, if I would turn this off, you would notice that our brush strokes look a lot better. So it's important to be aware that when you want to do your final renders, ensure that show points is off in general. And if you notice that your brush strokes don't look quite right, it might be because you have show points on one of your modifiers. And you notice that turning this on and off on the second one doesn't affect our brush strokes. It's usually when we do that for the first one. So that's something to keep in mind. The next thing we need to do is we need to specify where we want these brush strokes to be in the first place. So what I want to do is I want to isolate these brush strokes to exist in the crevices. The next thing I'm going to do is I'm going to adjust the seed just to make it a bit different from the other one. It doesn't really matter, because let's make it 10. And because I want to have it be a lot denser, I would actually reduce the distance minimum quite a bit to 0.01 maybe. Just look at the distance and see what's going on. But it's be a lot easier to tell once we've actually set up where we want the brush strokes to be in the first place. To do that, I'll just go over to the density factor, and I'm going to click on this button. To paint our vertex colors, you go into vertex paint mode, tab into vertex paint mode. We have an attribute here already, so I'm just going to name this crevice density. And now I'm going to come over to the modifier and select crevice density. Now we have our points back again, and that's because our vertex colors are actually white, setting in the modifier that we want to have points on all of our mesh, right? To change this, what we need to do is come over here and select our primary color to be black. And then come over to paint and select set the vertex colors. And now our vertex colors are black and we no longer have brush strokes. So now we just have to paint white. So let's go back and select our default color to a pure white. And I'm going to just reduce the radius of my brush a bit. So I'm just going to target the little crevices over here and I'm just going to paint white. Now don't worry if you're not seeing brush strokes yet. That's because we still need to adjust the density of our brush strokes. So I'm just going to paint this for now. Okay, good. So now I want to have a lot more brush strokes in this crevice here, right? So what I'm going to do is come over to density maximum. I'm just going to move this to like 2000. Right? That's still not enough. So I'm going to go 5000. Okay, cool. So I think this is good enough. We can always adjust this later, but yeah, so I'm just going to go around and paint the rest of the mesh. All right, so now I have my points where I want them to be. So if we were to look at both layers now, you'll notice that we have quite a bit of coverage actually. And I think that's pretty cool. I think I could also just adjust the density of this one a bit more. Maybe I could make it 500. So now we have a bunch of points where we want them to be. I'm going to turn this one off again. Now we have these points, right? But then we also need to do the same things we did. We need to have these attributes that we can use to sample our brush strokes again. And to do that, we need to also set up the names of our attributes. Previously, we used the T-space coordinates, point normal, point position, and everything like that. And we would need to change the names because if not, we're essentially overriding the attributes for this one because they have the same name. So I'm just gonna come over here and call this T-space coordinates 2. So the names are different between the two different modifiers. We're also gonna copy, again, this is quite tedious, and this is where making this into an add-on will be very helpful. So now we can preview our brush strokes. For next, we're gonna just copy this one, duplicate this, Shift D, duplicate, and then I'm just gonna change this one also. All right, cool. So now, if we were to look at the alpha value of our brushstroke mask, you should see our brushstrokes. You may have noticed that our brushstrokes are actually not straight. I'm looking head on right now, but our brushstrokes are diagonal, which is going to be a problem because it's not following the direction of the crevices. And this is actually the case because of the way our UVs are set up. And this also leads us to understanding how we can use the direction setup to control the direction of our brush strokes. Right now, if I was to preview our brush strokes again, you see that they're quite diagonal, right? And we could see this better by coming over to the UV editor and switch edit mode. This is what our UV map looks like right now. You can see that the UV islands are actually rotated diagonally. This was done so as to save texture space, to use as much texture space as possible, right? It's actually going to affect the direction of our brush strokes because we're using the UV map to generate a direction for the tangent. And that is why we have diagonal brush strokes. If I come over here and rotate the UVs, you notice that our brush strokes are actually rotating with it, right? We don't want to do that because that's going to affect our pumpkin textures because it's baked to this UV map, right? So what we need to do instead is we can create a second UV map and then edit this UV map and then switch it up to ensure that we're using the same UV map in our geometry node modifiers. But before that, I'm going to change the name to UV map to something. Doesn't matter. And then we're going to come over here and select the right UV map, which is UV map. So now we can do whatever we want to this UV map and not worry about affecting the texture of our pumpkin. Well, in order to ensure that our brushes are straight, you could rotate the islands and try to get something straight, but the islands are not completely straight themselves. Some parts would be straight and move along the trajectory of the mesh. Other parts will not be. I think it would be easier for us to see if we did this. Right, so now we could see it better, right? So you can see that although some parts are straightening up, some other parts are not. One way we could try to fix that is to straighten these UVs. And to do that, we could just try picking a face, selecting an edge on that face. Okay, so I'm going to go SY0. What I'm doing is I'm scaling the edge along the y-axis. On this one, I'm going to scale it SX0. And then here I'm going to press SX0. And then for the bottom one, SY0. And then we're going to select this face, press Ctrl L, right click and click follow active quads. Now we don't really care about anything other than ensuring that our brush strokes are a lot straighter. So don't worry too much about the fact that, the island is changed shape or whatever. And if you're looking here now, you notice that our brush strokes are a lot straighter. Now we have to worry about the brush strokes on the inside here. This island is a circle. You could try straightening it. But of course, it's not going to be perfect because this doesn't necessarily flow accordingly. But this is where painting our brushstroke direction will be very helpful. I'm going to increase the density of his brushstrokes here. Some brushstrokes, like these ones over here, flow pretty nicely. However, this one's angled in this direction, while instead of it to be in this direction. Some of these other ones are like that too. And one way we could solve that is by painting our brushstroke direction. And you might not even need to fix that depending on the style you're going for. But if you want your brush strokes to behave predictably, it makes sense to ensure that your islands are following a particular direction. And you don't have to worry too much about being super precise. I could have done it in so many different ways. I could have also just like selected a seam and marked the seam and done a quick UV unwrap, or I could have just used Smart UV project to also like get this done. However, you can't really predict how it's gonna work, and some parts will still end up being round like this, and also this one too. And ultimately, this particular system is going to change in the future, but you're still going to have the option to use UV maps to generate tangents. Next, what we're going to do is try to see how much we can fix the direction of our brushstrokes in this part of our mesh. You could just leave it like this, and I'm sure it's going to work pretty nicely, but I just want to use this to demonstrate how we could paint direction on our mesh. We need to go over to the modifier that we're editing, which is our crevices modifier, and come over to direction. And we are going to click on this button over here. And this now allows us to paint brushstroke direction. Now it's broken. Everything is green in every different direction. So we're going to have to go ahead and paint the direction of the brushstrokes. Tab into vertex paint mode. Now we need to create a second attribute in here. So we just come over here and click the plus button. I'm going to call this direction. Right? I'm going to click on add. Everything is completely black now. What we're going to actually paint is not white. What we're going to paint is either red, a completely red value. Red is 1, green 0, blue 0. Or we're going to paint green value, depending on what direction we want. I'm going to start with the red. If we go over to preview mode now, and I just painted red across this. We're not getting anything yet because we haven't selected the attribute here. So come over here and click on direction. And now over here, you notice that these brushstrokes are flowing in the right direction. However, these brushstrokes are angled in the wrong direction. Now we could just go ahead and start manually painting everything. But a better way to do this would be to come over here to paint and click on set vertex colors. And now everything is oriented along the x-axis of our tangent space, which is pretty much the same as having this be 1 on the x-axis over here when we change the direction back to the XYZ flow values. But I'm going to go back to the direction attribute. And now I'm going to come over here, and now all we need to know is what parts are we going to paint green to get our directions flowing. The brush strokes over on this region are oriented on the wrong direction. So all we need to do is to change this to a pure green. And then if we were to paint this, now you see our brush strokes are rotating to face the direction we want. So I'm just going to go over to find any ones that are not correct, and I'll just paint them green. I'm just going over and trying to see what I can do to get the brush strokes face where I want. Also over here too. But here is fine. I think this part is fine. So yeah, so essentially that's how we can paint your direction. Like right now we don't need to do too much because everything is green. If I would come over here and do this, right now we have different direction. So we decided we want different directions for this region. We could do that, but I want everything to flow along the principal direction of the mesh. Now, if this system feels a bit too unintuitive to you, that's fine. It's just a way for you to paint direction. It's a lot easier to control when you're dealing with like flat surfaces or surfaces that totally face a particular direction. It's easier for you to like paint that. However, in the future, I'm going to be implementing a system that's going to allow you to draw curves along your mesh. And then once you've drawn the curves, it will orient the brush strokes along the direction of that curve. So that's something to look forward to. So now we have these two. So how do we combine them? Well, combine them using this layer splat. So here we have top layer. For the top layer, I want the denser brush strokes to be in the top layer. So I have it here. And for the bottom layer would be this output here. So I plug this in here. And now we have both brush strokes showing up. Now we have brush strokes in our mesh. And I'm also going to come over here and turn off show points. I forgot to talk about the density factor. I'm going to turn off the first layer. So we just have this layer for now, just so I can talk about the problem that we're going to face. I'm also going to remove this one for now so it's easier to see the brush strokes. I'm going to talk about a particular problem, and that problem is not visible right now. However, if I were to go into edit mode and then go Shift A and add a plane, I just bring it down. I added a new mesh to this geometry, and if we go to the vertex paint mode, clicked on the crevice, you realize by default vertex colors are going to be white. This is something to pay attention to in case you're going to do anything else in edit mode where you're adding a new object. You're going to have to also ensure that you paint the surface black. And to do that, go into edit mode, select this face. I'm going to move to vertex paint mode. Then in order for me to select this space in vertex paint mode, I have it already set in edit mode. So now I can just come over to this icon here and click on face selection here. And now we have our face selected. Ensure that your primary color is black, and then go to paint and click on set vertex colors. And now it's black. So if I click on show points now, I don't have any points on this mesh anymore, which is what we want. So now, if I go back to material preview mode, you notice, although now we don't have any points on our mesh, we still have a brush stroke being projected on this plane. And you might notice that if we go into edit mode again, select just the pumpkin now, and if I was to move pumpkin around, it's following our pumpkin, which means that somehow the brush stroke is being projected through the pumpkin onto another mesh, but that mesh has to be in edit mode, right? If we had another mesh that was in object mode, that was added in object mode, we wouldn't have this problem. How do we solve this? Well, this is where our density factor comes into play. When we painted the crevices, we created this crevice density attribute. Now all we need to do is to use the same attribute over here. So I'm just gonna change the name over to crevice density. Let's go over to material preview. If I plug the factor of the crevice density into density factor, now we no longer have our brush strokes showing up on this part of our mesh. I'm actually gonna delete this now. Now we can preview both brush stroke layers together now. So how do we get to a point where we can actually use the brush strokes to make our object look like a painting? To do that, we need to calculate something called an image gradient by doing some very simple math, which is just pretty much addition and subtraction. What we need to do essentially is we need to use our derivative offsets that we have over here and our x and y derivatives to generate the image gradient. Now I don't need these guys anymore, so I can delete them. Let me frame this nodes, and then I'm going to tap N on the keyboard, come to the node tab here and change the label to original. So know that this is our original tangent space sampler. And I'm going to create 2 copies of this entire frame. So Shift D, and I'm going to move this one up here and make a second copy and move this one down here. So now I'm going to call this copy X derivative, and then I'm going to call this one Y derivative. We're then going to have to change the sampler. So I'm going to switch this over here from the default sampler to the X derivative sampler. And I'm also going to change this here too. So now we're sampling the brush strokes using the same tangent space coordinate that we calculated, but slightly offset along the X direction. And then we're going to do the same for the Y. So we're just going to drag this one over here and drag this over here. And then this is the same as that, but on the Y direction. So, and then all we need to do next is calculate the image gradient, which is essentially just the rate of change along the X and Y axis of the image texture that we are sampling. We're gonna bring in a math node, and then I'm gonna plug the result of this X derivative in here. And I'm gonna set this to subtract. And I'm gonna subtract our original brush strokes from the X derivative. If I were to preview this now, you'd notice that we're really only seeing the values on the X direction over here. And you can make this stronger or weaker by adjusting the amount of offset that we have here. You don't have to do that for both of them. You will just get like another value, like a value node here. So it's easy to adjust this derivative offset. Now it's going back to black because we don't have any offset. Let's make this 10. We get what we had before. I could make this 20, and now it's wider. We go crazy, I go 50, I make it wider. But I find that 10 works best for me. You can tweak that and see which one you like the best. We're also going to do the same thing for the Y derivative. So we're going to get output of our Y derivative and plug it at the top. And then we're going to drag this one over here and then subtract our original from our Y derivative. And then once you look at this, you're going to see that now we have a change only on the Y direction. And then again, you can adjust it a bunch if you want, but that's fine for me. And then finally, to construct the actual image gradient, what we need to do is to add a combine color, and we're going to plug the result from subtracting our original brushstrokes from the X derivative to the red channel, and we're going to add the result of the Y derivative to the Y channel. Now once we preview this, we're going to get something that looks like this. And then now we can actually send this output to our compositor. Now I think I'm going to make this into a node group. So now we have a new asset. You should expect to see 6 assets now instead of 5. And the 6th one is this image gradient. So now we need to create an output AOV. So Shift A, AOV output. And then I'm going to plug this in here. I'm going to call this Pumpkin Brushes. And for us to actually see the output AOV in our compositor, because if you look at our compositor right now, we're not getting any output AOVs yet. That's because we need to go over to the view layer properties, and then we're going to scroll down to shader AOVs. We're going to create a new AOV. And I'm just going to copy the name of this AOV and paste it here so that it has the same name. So now we've linked these two together. Okay, so now we're done projecting brushstroke textures on our mesh, and we can actually go ahead and stylize our mesh. But to do that, first we need to switch back to our normal shader. It should look like a normal pumpkin now, except it has a bunch of points. So we're gonna have to go and turn off show points. Make sure that both are turned off. Well, the next step is to add our final node group, which is the Stylize node group. We can go over to the compositing tab and we can take a look at our AOV to ensure that it's actually working correctly by just doing Ctrl Shift and clicking on the Pumpkin Brushes AOV output. And now if we were to go over to material preview, we haven't seen anything yet, and that's because we are not actually using the real-time compositor yet. Let's do that. All we need to do is come over here and click on always or camera, but I'm using always because I want to look around. And now you can see that we have our brush strokes on our mesh in the compositor, which means we can then use it to stylize our mesh. Cool. I'm going to mute this denoising node because we're in EV and we don't need it. And then I'm also going to mute the glare node just so we have more performance. But it's not going to be that crazy. And next, what we're going to do is we're going to drag in our last node group, which is the Stylize node group. And so we're just going to drag this and then put it in here. I'm going to make this a bit bigger so I can see. Plug in the rendered image in here, and then plug in our output AOV in here. This is what our final render looks like, right? But once it goes through the Stylize node, this is what it looks like. And I mean, it looks like a painting, although our brush strokes aren't exactly as visible as we expect. That's because we need to change a couple of settings. Now this way things kind of like slow down a bit because we're in the compositor. I don't have a GPU, so this isn't GPU accelerated in any way. And we're also using a quite high coherent kernel. It's at 20, but if I were to put this at 0, it would have a lot more performance. So really what's actually dragging a lot of our performance is the coherent filter. Although we've turned off a coherent filter, we are not seeing our brush strokes, which means our brush strokes are not affecting our image yet. And so to get that working, we need to increase our brush stroke strength. And once we do that, you start to notice that we're getting something. There's a couple of ways we can affect our brush stroke strength. We could increase the strength here directly by doing what I'm doing here. Another thing that also affects brush stroke strength is if I were to go back to shader editor, adjusting brush stroke contrast also increases the effect. So right now it's at 1. If I were to drag it, you notice that we're getting stronger effect. We have our brush stroke strength at 30, and we have our brush stroke contrast at 1. Next is extend brush strokes. Now what this does is it extends our brush strokes beyond the boundaries of our mesh. So if I put this at 0, notice that we no longer have parts of our mesh stretching outward. But if I would go back to 9, it's popped out. However, our mesh doesn't yet look particularly painterly yet. And that's because the coherent kernel size right now is at 0. If I were to put this at 10, you'll notice that now our pumpkin looks a lot more painterly. You also notice that we've kind of smoothed out the brush strokes quite a bit, and you might be wondering that, okay, what effects are the brush strokes actually doing to our final image? And you can see that by turning the stroke strength off. This is what our mesh looks like with just the coherent filter on. But if we turn our brush strokes back on to 30, now we're kind of directing the coherent filter, directing the flow of the brush strokes. But it still doesn't seem enough. So we could take it to like 50. However, we're still not getting enough visibility, and that's because we don't have enough contrast in our brushes. This is something I should have talked about earlier, but essentially we would have to go really high, maybe like 500. You can see our brush strokes a lot more clearly, especially when we look over at the crevices where we had a lot of brush strokes. There's a bunch of different ways we could try to make the brush strokes more prominent. One of the best ways is to come over to the shader editor. So if I were to go back to disable the compositor, let's preview the original brush strokes now, for example. Now, depending on how you author your brush stroke texture, you would have to adjust the brush stroke contrast depending on the actual base contrast of your initial brush stroke textures. I could increase the brushstroke contrast quite a bit for the first layer. For this particular brushstroke texture, I like to go for like 4. And then for the second layer, I would go higher for like 6. But I find that like having the top layer have a higher contrast than the bottom layer usually makes things look a bit better, because you would want the brushstrokes to be more prominent in the layer where you have a lot more density. So you could have just initially made a brushstroke texture that is this high contrast without having to adjust this, but having that option is also good. So you can go low contrast, and then over here you can adjust the contrast to your liking. Now I'm going to have to do this for the X and Y derivative. So for this, I'm just going to come to contrast about 4, and then Here I'm gonna go 6. And then here, I'm also gonna go 4. And here I'm gonna go. So now if we were to preview our image gradient, you see that it's a lot more pronounced now. If we were to now look at the final image by coming over here and turning on our compositor, now you can see that we have way more brush strokes visible. And we can also change the HDRI. Another thing to keep in mind is that lighting also affects how visible our brush strokes are. So the more high contrast your lighting is, the more visible your brush strokes will be. And now you can see that this HDRI has a brighter hotspot in this region, and this makes our brush strokes even more visible. So this kind of gives like an impasto effect, and this will look even better once we add bloom. And now it kind of looks like an impasto, where it seems quite heavy on the parts where we have more light. Your lighting plays a huge role in determining how the brush strokes look. For now, I'm gonna go with this. You notice that now we can see a lot more brush strokes along the silhouette of our mesh, and this is being affected by the extend brush strokes. I usually stick with a value of 9. 9 usually looks the best for me. We're kind of pushing the effect quite crazy. So if you go back to like a 20, you can still see that our mesh is being extended beyond its silhouette. If you set this to 0, we no longer have brush strokes along the silhouette of our mesh anymore. So I'm going to set this one back to 9. And yeah, so I'm going to play around a bit more with this effect, and then we're going to continue from there. I essentially ended up increasing the density of the point clouds. So the initial point cloud, the first layer, I increased the density max all the way up to 1000. And then for the second layer, I increased the density max all the way up to 8000. This is all just personal preference. In the compositor, I'm using stroke strength of 10 and core size of 10, and then 71 2. So this is what we have right now for the pumpkin. And what we're going to do next is we're going to do the same thing for all the other objects in our scene, starting with the apple. First things first, we need the texture splat. So you just drag this onto the mesh, and we have our modifier on our mesh. Next, we can show points, so we can see the points on our mesh. And like I said before, sometimes you won't see anything, and that just means the distance value is too high. So let's take that to 0. And yeah, it's not getting any points. That's our density max is too small. So the previous one we went with 1000 for the density max. So I guess I can also go for 1000 over here too. Now we have stuff going on here, and then I like to take the point size down. I'll just go with 0.005 like we did last time. So we have this. I'm going to adjust the distance minimum so that we don't have points too close to each other. So just adjust this. Okay. And I think we need more density. So let's go 2000. Depends on the size of our mesh. Remember, the apple is quite a bit smaller than the pumpkin, so we might not need as many points to cover up this small surface area. Could always adjust things if I want. And then for distance minimum, I think I could push it a bit lower, so maybe 3.01. Points are not overlapping and it seems to be fairly dense. So the next thing to do is populate our attributes with the right names. So again, make sure to check our UV map. Now our UV map for the apple is different, so it's a different name from the default value in our modifier. So I'm just gonna paste this over here. So next is to get our attributes in the shader editor. So attributes, get that over here. And then copy this, paste. Next, we need to sample our brush strokes. To do that, we're going to use the T-Space sampler. So let's drag this in here. Plug our T-Space coordinates in here. Now we can get our image texture. Use the brush stroke and then plug our sampler in here. Now we should be able to see our brush strokes. And now let's check out the flow of our brush strokes. Some parts are diagonal and some parts are horizontal. You could go with this if you want. This is very, very much okay. But I think I'm going to go over to the UV editor just so I can see, what we're working with. Okay, this is quite chaotic. I'm just going to change this to create a new UV map. And then we're in edit mode right now. Hit A, U, wrap. We look at our brush strokes again. Now they're a lot more directional. So I think what we're going to do next is, since we've sampled our brush strokes, all we need next is splat mask. So get this node group. The second to last node we need is layer splats. Come over here and then check it out. Again, we can adjust the contrast of our brush strokes. I think these brush strokes are enough, but we're still going to need a second layer, but that's going to be for the stem because we barely have any brush strokes in the stem, and I think we need to go a bit further with that. All I'm going to do is just duplicate this. And then for the second one, for density factor, we're going to get a vertex attribute. Let's go to vertex paint mode area. The color of our apple was painted using vertex colors, so that's interesting. So we're going to create a new vertex color. I'm going to call this stem density. Then now just going to paint our stem white. And also the insides, so the crevice. So that's done. So come over here, stem density, assign it over here. Now we have some points over here. I'm gonna reduce the size quite a bit. I'm gonna increase density to 8,000. It's not as much as I would like. Let's just go crazy to 100,000. Why not? Going quite crazy with it. 500,000. That's a lot. I think we're going to have to still reduce the density quite a bit. I just want to make sure that we have enough brush strokes. The next thing we're going to do is fill our coordinates. Now we have that set up. And then all we need to do is duplicate this one over here. And then here, I'm going to use this standard space coordinates 2. And now because we painted our density, we're also going to need a density factor. Stem density is what it's called. And then plug this layer. So if I were to look at our brush strokes on the stem now, let's take a look at it with the mask and everything. We need to increase the scale of the textures. Now we have something. For the stem, seems like our brush strokes are going on the horizontal axis. I think we wanted to go in this direction rather than this direction. One easy way to do this is to go to the UVs and rotate the UVs. You could paint it too if you want. We haven't plugged in the alpha, so let's plug our alpha in here. And we also didn't plug in the alpha over here too, so let's do that. Now I think our brush strokes actually maybe a bit too much, but let's check it out. Also, let's increase the contrast to 6. I think in comparison, it's quite a lot. We have just way too many points. So I'm gonna go back to like 25,000. I think this works. The more points you have, the higher the scale of your brush strokes need to be. So keep that in mind. Next step is to calculate our image gradient. We need the image gradient node. So we'll just drag that from our asset browser, and we need to also group this. So I'm just gonna join in a new frame. And in terms of the derivative, I think we can leave it as an offset of 10. If we were to look at our image gradient, remember it's supposed to sample the actual derivatives, because we just pretty much subtracted the same values from themselves, which is why we got 0. We have our image gradient now. All we need to do now is output it as an AOV. Remember, we also come here and also set up our AOV. So now we can move over to the compositing tab. So I'm going to disable compositing for now. And then I'm going to get the pumpkin also, because I want us to take a look at how we're going to combine the two AOVs together. Because right now, you're going to notice that we're only getting brush strokes on our pumpkin. That's because we are actually only sending over the pumpkin AOVs to the Stylize node, where you're going to have to combine the AOVs together. To do that, you need an alpha over. So this is our pumpkin brushstroke, and this is the apple. And so we're going to plug both of them. So plug this in there and plug this in here. And if you click on this, now they're both here. Now we can plug this into the AOV socket. And once we preview this, we should have brush strokes on our apple. And they overlap really nicely. Alright, so I've gone ahead and done the same steps that I did for the pumpkin and the apple for every other fruit in the scene. And now, as you can see, we have brush strokes on all of them, and they're all looking pretty nice. But there's also brush strokes on the tablecloth as well. And if you were to look at the entire AOV output, then this is what you'd see. Right now, we are pretty much done. However, there is actually a problem that I would like to show you. Now, you might notice that my compositor node tree is a bit different, but don't worry about that. I'll tell you exactly why that is. But for now, just pay attention to what's going on here. So when you follow the exact same steps for the pumpkin and for the apple, so you're going to get pretty much what I have right now. You're going to get pretty much the same thing, and that's what this node is outputting to the viewer node right here. However, you're going to notice that if you zoom in, take a look at the edges of our pumpkin, for example, you will notice that there's a weird color bleeding happening that's going from the pumpkin into the wall. It's also pretty visible over here too. And that's not exactly what we want, because no painter would actually paint this way. You wouldn't expect to see streaks of paint just sort of running out of an object like this. The reason why this is happening is because essentially what we're doing is we are displacing the entire rendered image all at once. We have our AOVs here, and so our AOVs is not able to tell that this is a separate object from this, and so it actually displaces the pixels of the pumpkin into the wall, following this sort of like X displacement that we have going on the red channel here. And so this kind of becomes a problem, and this effect is not only isolated to the pumpkin and the wall actually, because if you were to look at the apple, for example, we also get the same problem, because it's essentially the same thing, right? The pixels are being pushed in this direction into the pumpkin. But when it comes to the fruits, the effect is not as bad, because you'd kind of expect that, colors would sort of like bleed into one another. And they also have quite similar colors too. So it just sort of works. And then obviously it really gets more obvious the more you zoom in, the closer you are to the object. And you could also see it too with the banana and the pear right here, but it kind of makes sense, it kind of sells the painterly effect, but it's very obvious when we're looking at the pumpkin and the wall. And so to fix this is actually pretty simple. Essentially what we need to do is we need to figure out a way to separate the wall from the fruits and then displace the pixels of the wall separately from the fruits. So essentially what we're trying to do is we're trying to create like a foreground and background separation. So we can displace the background first, then also displace the foreground, and then we can composite it together and we get our final image. A way I found to do this that works really well for our use case is to actually use the AOVs themselves, right? If you come over to the compositor, you would notice this extra 2 frames that I created, the bottom layer and the top layer. What I'm doing here is I'm taking the AOV for the wall. So this is the AOVs for the wall, right? But you notice that we have separation from the wall and every other thing in the scene, right? So that's pretty much what we need. So if we were to plug this wall brushes AOV to a separate color node, which gives us our RG, B and A channel, we could use this alpha channel to sort of separate our background from our foreground. And to do that, what we need to do is set the alpha channel of our fully rendered image such that it respects or it follows the alpha channel of our wall brushes. And to do that is there's a really simple node called the set alpha node. It sort of adds an alpha channel to an image. So once we plug our rendered image into the set alpha node and we plug the alpha channel of our wall AOV into the alpha socket of the set alpha node, you'd get this, which is what we want. So now we have only the wall in the image. This is exactly what we're going to also do for the foreground. And the foreground is just slightly different because we are combining all other AOVs together. And then we're separating the alpha channel and using that alpha channel to set the alpha channel of our rendered image, which separates our foreground from our background. And then essentially what I'm doing next is I'm running both layers through a glare node, which adds bloom to the image. Then do the same thing for the wall, for the background, right? And now all we need to do is pass it through our stylized node group, and this displaces our pixels, and it's not going to affect the other parts of the image. We're actually not going to run a Kuwahara at this stage. We're going to run the Kuwahara at the end because Kuwahara node gets pretty intense, especially the higher you go with the kernel size. So having multiple Kuwahara processes is going to make our renders slow and unresponsive in the viewport. So it makes more sense to just do it at the end. It pretty much gives us the same effect and it's a lot more performant. So I just turn the Kuwahara kernel size to 0. And then we're going to do exactly the same thing for our foreground, right? Displays the pixels. And you might notice that we have some pixels protruding out of the silhouette of our object. And you might be thinking, is this because of what we are trying to fix in the first place? But it's actually not. If you recall, this is essentially what the extend brush strokes slider does. So if I set this to 0, you see that we have a clean alpha channel, right? But I like to have it at 9. And then from there, all we need to do finally is run the result of both displacement into an alpha over node, which will use the alpha channel to combine them together. And we've completely evaded the problem of having those streaks of color sort of coming out of the objects and entering into the wall. Finally, we pass it again into our node group, but this time we're going to turn off brush stroke strength and extend brush strokes, and we're only going to deal with the Kuwahara now. And I put the Kuwahara at 13, which I think works really well, especially for the final render, because the Kuwahara node is resolution dependent. So you're going to have to adjust your Kuwahara depending on the resolution you're using and also depending on how close you are to the objects. So these are things that you're just going to have to keep in mind, but this is essentially what we want. So yeah, that is essentially what all these node groups do. And like I said, we can have more than just 2 layers. We can have as many layers as we want. It all depends on what you want to do. and depends on the kind of problems you're trying to solve. Now, obviously, this can get quite cumbersome, and it's not hard, but it's cumbersome to deal with. All right, so this is something that the add-on that I'm working on is gonna solve. It's gonna have like an interface at the end panel, like how most add-ons do, where you could like adjust a bunch of settings and everything. And you'd also be able to create layers, allow you to sort of like select an object or a material and then add the material to a particular layer that you want, and you can create as many layers as you want without having to sort of like come into your compositor node tree and sort of like mess around with a bunch of nodes. It's just going to automatically group the AOVs based on layers that you've set up and then combine it all together and then pass it through a coherent, and then you get your final result. So with that being said, I'm just going to come over here and delete these nodes because we don't need them anymore. I'm also going to delete the denoise node because the coherent is going to do all the denoising for us. That also allows us to save processing power and we have a lot more speed. We'll go back to our layout tab, and what I'm going to do is I'm going to isolate the pumpkin and I'm going to show you exactly how I would animate the seed values on the pumpkin, and then you do the same thing for every other one. All right, so I'm going to show points so we can see. So I'm going to go to seed evolution. I'm going to use a driver and just go #frame divided by 4. And then, so I'm going to do the same thing for the second one, #frame, and do the same thing for the Apple. This is what it looks like rendered in Cycles. And yeah, this is pretty much it. Obviously, once you've rendered the frame, you can still go ahead and, tweak a bunch of stuff. I went ahead and just reduced the sharpness to 0.7. Maybe I could have it like 0.8. Okay, so now I'm going to render the animation. All right, so our animation is done. So that's about it really for this video, and I hope you found this helpful in helping you bring your painterly animations to life. Like I said before, in the description, there is a link that leads you to where you can download the asset file. And finally, we also have a Patreon that you can subscribe to. And this Patreon is going to give you access to a lot of files, not just files related to this particular project, but you're going to get access to blend files for other projects. And you also get access to a growing library of seamless brushstroke textures that you can use in your painterly projects. And pretty soon, there's going to be a video coming out first on Patreon that goes over how I make these. I would also like to give a huge shout out to the Control Alt Delete Discord. There's a lot of folks over there that are doing amazing work in NPR and Blender. And if not for them, I'm not sure I would even make this video in the first place. There's a lot of awesome encouragement from people over on that Discord, which really inspired me to want to create videos talking about this system and how to use it. A link to the Discord is going to be in the description. If you're interested in anything NPR, really, that's like your best bet. It's really awesome, the kinds of things that people are able to make over there. With all that said, again, I hope you found this video helpful, and I hope you stick around, subscribe to see Particle Painter evolve and grow into something that will hopefully be a really useful tool for a lot of people in the community.